Okay guys, we're in Advanced Math Trig, Mod 7. Today is Tuesday, April 14th. So on the top of your notes, left-hand corner, 4-14-20. If you remember, Thursday we graphed circles. Monday we graphed ellipses. Today we're graphing something called hyperbolas. Now stay with me on these. These are a little weird, a little different than a circle or an oval-shaped ellipse. Now the obvious first difference equation-wise, and like yesterday and the day before that, we're going to do 4 problems on the front and one more challenging, detailed algebraic expansion type problem on the back, all dealing with a topic called hyperbolas. Now you'll see what a hyperbola looks like when I'm done graphing the first problem. But first, you got to be able to recognize, ooh, that's a hyperbola I'm about to graph. And there's one obvious thing that stands out. If you look at all 4 of these problems, minus in the middle, minus in the middle, minus in the middle, minus in the middle. If you remember, circles were what? X squared plus y squared equals r squared. Ellipses were x squared over a squared plus y squared over b squared equaled 1. Hyperbolas, yes, also must equal 1 when they're in standard form. Just like an ellipse, it has to equal 1, but there's a minus in the middle. So hyperbolas, yes, have x squareds, and yes, have y squareds, and yes, they're equal to 1, but there's a minus in the middle. So the second you see a minus in the middle, your brain says, oh, that must be a hyperbola that I'm about to graph. Now, how do you graph these? Well, just like the last 2 days, we got to start out by finding the center of our picture. This is a good old x squared and a good old y squared, right? There's no numbers in the parentheses like this one down here. Notice number 3, it says x plus 2, y minus 1 in parentheses. So the center is going to be somewhere other than the origin. On this problem, number 1, there's no other numbers involved. It's just good old x squared, good old y squared. So the center, of course, is 0, 0. So I'm going to go to my coordinate system, put a dot on the origin at 0, 0, and label that CR for my center. Now, you start graphing these just like you did the ellipses. The x squared has a 9 under it, correct? And the square root of 9 is what? 3. So I go to the x-axis and I go right 3 and left 3 and put dots. The y squared has a 4 under it. Now the y-axis runs up and down vertically, and the square root of 4 we all know is 2. So I go up 2 and down 2. Okay, now freeze. Do not connect those dots up and make an ellipse. There's not a plus in the middle. There's a minus. I'm going to draw a hyperbola. How do you do that? Okay, here's what you do. You ready? First of all, you use those 4 dots to create 4 dots in the corners and create what looks like a rectangle. So guys, watch. You go to this dot here. Look where my pen's at. And go up and put a dot that's even with the top dot. And go down and put a dot that's even right there. And then go to this left dot and go up a couple and put a dot in the corner. And go down a couple and put a dot in that corner. And it looks like you've just created a nice rectangle. And what you do is draw a dotted imaginary line that serves as the diagonals of that rectangle. And that's called an asymptote. Remember, an asymptote is an imaginary dotted line that you really can't see. It's just there to guide how big to make my picture when I start drawing the curve. So guys, draw an imaginary diagonal through there and draw an imaginary line that's going diagonally through those corners. And once those diagonal lines are created, you're going to draw a hyperbola, which is a curve or curves pointing in opposite directions. It's going to either point right and left, or it might point up and down. How do you know which direction to draw it in? Go back to the original problem. Now listen to this rule. Whichever letter is first, in this case, the x squared is first, that tells you the direction it's going to open. Since the x squared is first and the x-axis runs left to right, my hyperbola is going to open left and right. You basically go to that dot, draw a curve to the right that gets really close to the dotted line, but never crosses it, and then draw his reflection on the other side and draw a curve pointing to the left that fits in between the dotted lines. The dotted lines are there to guide the width of your curves. It's almost like it's a satellite dish facing east and a satellite dish facing west. And again, it went left to right along the x-axis because the x squared came first. Okay? Look at number 2. There's a minus in the middle. So your brain says, oh, that's a hyperbola. However, it's not equal to 1, isn't it? Is it? We said all hyperbolas must equal 1, just like ellipses. So just like ellipses, for you to get this into standard form, we're going to divide both sides by 36. That will create the 1 we were looking for on the right. Agreed? And on the left, we've got 4 over 36, which we're going to reduce. And we've got 9 over 36, which will also reduce. So 4 over 36 would be what? Y squared over 9 minus, isn't 9 over 36 going to be x squared over 4 equals 1. That's my standard equation. I go to draw a picture. Hey guys, I got good old x squared and a good old y squared, right? So the center again is 0, 0. Put a dot on the origin and put CR. Now careful, the y squared has a 9 under it, so I'm going to go up 3, down 3. The x squared has a 4 under it, so go right 2 and left 2. Make a rectangle, corner, corner, and corner. Draw a diagonal there and a diagonal there. So I've got 2 asymptotes going right through the center of my hyperbola. Now careful. Notice the y squared is first this time. If the y squared is first, my hyperbola will open up and down along the y-axis. And you go really close to the dotted line there and really close to the dotted line there. And then draw his reflection, his twin brother on the other side. And my hyperbola, with the proper width being drawn, opens up and down. So it's a satellite dish facing north and another one facing south. Okay? Next problem. X plus 2 squared over 6 minus y minus 1 squared over 12 equals 1. Minus in the middle, it's a hyperbola. It's equal to 1, so it's in standard form. I need to do no algebraic manipulation. It's ready to roll. It looks like the center is going to be, okay, now careful. Some of you are still messing this up. It's the opposite signs of what you see. So the center is -2, comma, +1. So I'm actually going to go left 2 and up 1. Put CR for center. Under the x squared, there's a 6. The square root of 6 is 2.4. So I'm going to go right 2.4, left 2.4. The y, or y squared, has a 12 under it. When you square root that number, you get 3.5. So I'm going to go up 3.5, down 3.5. Don't draw an ellipse. This is a hyperbola. So I need a corner, a corner, a corner, and a corner. The asymptote, or the diagonal, must go through the center of your hyperbola. So guys, I've got one diagonal going that way, and the other diagonal going this way. And because the x squared is first, it opens left and right. So it's a really wide hyperbola opening right and left. It should get really close to the dotted line and not quite touch it. Okay? And then our last quote, kind of normal one. If you look at this guy here, I noticed the 20. That has to be a 1. You cannot graph this unless it's equal to 1. So I'm going to divide both sides by 20. That creates the 1 on the right side that we were looking for. Do you agree over here on the left, this quantity, this parenthesis is understood to have a 1 in front of it, so it won't cancel with the 20. So we've got y minus 2 squared over 20 minus, now do you agree the 5 over 20, the 5 will cancel, the 20 will become what, a 4? So x squared over 4 equals 1. I got it successfully in the standard form. Careful, one of the most missed questions when you do your assignment. The center of this hyperbola is not 2, 0. Guys, the x squared is here. Look where my finger's at. The y squared is there. It's always x, y. Agreed? So the center of this hyperbola, since it's just good old x squared, is 0. And then it says y minus 2, so my y coordinate's 2. So the center is up 2 right there. Agreed? The y squared has a 20 under it. The square root of 20, oh boy, is 4.5. So I actually have to go up 4.5, down 4.5. The x squared has a 4 under it, so I'm going to go right 2 and left 2. Draw the corner, the corner, the corner, and the corner of a rectangle. I draw a diagonal coming through the center and another diagonal going through the center. And because the y squared is first, it opens up and down along the y-axis. So it's fairly narrow, opening downward, and it's going to be a little hard to see, but it opens upward right there. Wow! And I did it. I drew my hyperbola. Okay? Finally, the last problem for today. Oh boy, another one of these. Put a big star by it. 9x squared minus y squared minus 36 minus 6y plus 18 equals 0. That certainly is not in the standard form. Agreed? So just like yesterday, we're going to have to attack this, manipulate it algebraically by completing the square and putting things into families or groups like we did yesterday and on Thursday. Now, careful here. There is the minus and followed by the y squared. Remember when we did these problems, the minus was always right in the middle, wasn't it? So whichever squared letter has the minus in front of it has to go second when we arrange our families. So the 9x squared, because he's positive, goes first. The letter that's part of his family is the minus 36x. I'm going to leave a blank space. Then I'm going to write minus y squared minus 6y, leave a blank space. And since that positive 18 doesn't belong to the x or the y family, either one of them, he gets shoved to the other side. So if I minus him over, you agree that would be negative 18. Okay, now careful. We still have a little work to do here. You do not cut 36 in half and square that answer. Remember, you cannot complete the square when there's a number in front of the squared term. Guys, we got to first factor out a 9, right? You're pulling out a GCF of 9, giving you x squared minus 4x and a blank space. Don't copy. Understand how I got that. Do you agree if I factor out a 9, it gives me x squared minus 4x in a blank space? And notice here, there's a minus in front of my y squared. If I'm going to complete the square, I don't want a number in front of the y squared. So technically, I'm factoring out a -1 from that family. And all that does is change the signs to y squared plus 6y, blank space, equals -18. You've got to concentrate and focus. Now, I'm going to pretend that 9's not there for a second. Take -4, divide by 2. You would get what? -2. And then square that answer. So that'd be plus 4. Whatever you do to one side, you got to do to the other. But remember, that's really not a plus 4. Oh, remember there was a 9 in front of that whole group. So 9 times 4, guys, that's really 36 that I'm adding. Okay? And then cut 6 in half. That'd be what? 3. 3 squared would be plus 9. Whatever you do to one side, you do to the other. But that plus 9 has a -1 in front of it. So it really is -9. And if I have a -9 on one side, -9 on the other. So talk your way through that. Be careful. So cleaning this up even further, this is going to be 9. And then remember, this perfect square trinomial will factor into a binomial squared. What did you get when you cut -4 in half? Wasn't it -2? So this is x minus 2 squared. Minus in the middle. Notice the minus. And then this group was going to be y, and then what? Plus 3 quantity squared, because that's what you got when you cut the positive 6 in half. Now on that side, I add -18 plus 36 minus 9. Do you agree -18 plus 36 is what? 18? And then minus 9 gives me 9. You're not done yet. Every hyperbola must equal 1. So I'm going to divide both sides by 9. So I did it. This thing in standard form should say x minus 2 squared over, now careful, that's a 9 and a 9. Don't they cancel? Giving me a 1. That's okay. You're allowed to have a 1 on the bottom. Minus, and then y plus 3 squared over just 9 equals 1. There's my final answer. I've successfully got it into standard form. Okay, so that's the challenge problem. See if you can do that. I can almost promise there's one of those towards the end of every ACT test you take. All right, let's give it a shot here. Your homework for today, 4/14. Today is Tuesday the 14th. So this little assignment, this 4-question homework or assignment or quiz, whatever you want to call it, 4 problems, big deal, due by noon tomorrow, by noon on Wednesday. You graph the first 3 hyperbolas, draw nice, neat pictures, take your time and get all your dots in the right spots. And then on number 4, all you've got to do is complete the square, group your families together, manipulate that one, and try to get it into standard form like I did on my last problem. So there's your 4 problems. You might want to hit pause at this point. Those are your 4 homeworks that are due tomorrow on Wednesday by noon, okay? Good job, good luck. See you tomorrow.